woman in a dead observatory chased fire for 23 years, and the answer finally arrived as dirt smeared across a window. High in Chile's Atacama desert, Dr. Mara Velez worked inside a collapsing dome where rust flaked like old skin onto her notebooks. The world had already stamped her a failed materials scientist after grants dried up, colleagues vanished, and her miracle polymer refused every test. She was trying to build a skin for machines, a heat shield layer that could survive black box temperatures hot enough to erase metal. Her lab looked less like the future and more like a shipwreck, packed with cracked ceramic cookplates, scavenged vacuum jars, and wires patched with tape. Wind bullied the observatory night after night, making the telescope groan while handwritten failure maps slapped against its metal ribs. Every sheet recorded another dead end, another formula that bubbled, fractured, charred, or peeled away in dust. She did not fail once or twice in some neat montage, but thousands of times across birthdays, droughts, layoffs, and funerals. She melted blends at dawn, cooled them by moonlight, and woke to brittle flakes where resilience was supposed to be. She tested minerals pulled from desert soil, industrial scraps from scrapyards, and homemade binders that smelled like smoke and bitterness. The agency that once funded her dream eventually canceled her grant with a letter so thin it felt lighter than the years it erased. She pinned that rejection beside her formulas anyway, using insult as data because pain could still point toward a pattern. Money ran so low that expensive equipment became impossible, so she built procedure from household physics and ruthless observation. She used ceramic cookplates to mimic heat shocks, layering samples in jars where vacuum seals were improvised from machine gaskets and stubborn hands. When sensors failed, she watched color shifts, blister shapes, and edge curls like a desert tracker reading hoof prints in dust. Her notebooks became atlases of defeat, each page dense with temperatures, textures, timing mistakes, and ugly sketches of cracks. Instead of hiding failed attempts in boxes, she taped them in plain sight across the observatory walls until the room itself became a map of learning. That strange strategy changed everything because memory lies kindly, but walls covered in evidence tell the brutal truth. Looking up from one bench, she could see which mixtures failed fast, which warped slowly, and which always collapsed after rapid cooling. She began sorting disasters into families instead of individual embarrassments, grouping them by blister pattern, ash residue, and the sound they made when tapped. The chaos that once mocked her slowly became a language, and every broken sample started speaking with a clearer accent. Still, years kept passing, and success stayed hidden like water under stone. Her hands aged beside the work, knuckles roughened by heat, fingernails darkened by soot, and wrists lined with tiny burns no one applauded. Outside, the Atacama stretched pale and unforgiving, a planet-like emptiness that made her mission feel both ridiculous and necessary. If anything on Earth could teach survival under extremes, she thought, it was this desert where sun punished everything by day and cold stripped it bare by night. She stopped chasing perfect formulas and started chasing surviving behaviors, asking not what looked elegant, but what endured abuse. That shift sounds small, yet it rebuilt her process from vanity into utility. She mixed ugly compounds that no polished lab would proudly present, because beauty in research often dies before pressure arrives. Some samples bubbled into black crusts, and instead of discarding them, she studied why those crusts clung when smoother films fell apart. She noticed that layers with irregular carbon-rich scars resisted sudden heat better than glossy surfaces designed to impress reviewers. So she leaned toward mess, introducing ash, grit, and stubborn mineral impurities that respectable chemists might have filtered away. Failure maps multiplied again, but now they bent toward a pattern she could almost feel in her palms. Then one evening, after a dry windstorm rattled the dome like bones in a drum, she wiped a window with the back of her sleeve. Meteor dust and soot had smeared into branching gray veins across the glass, leaving a thin, dark lattice where the gusts had pressed hardest. She froze because the pattern looked eerily similar to the stress fractures in her test plates. Except this time, the dark residue sat where protection should be. On the window, the dust had arranged itself into a sacrificial network, absorbing force, spreading heat, and clinging exactly where smooth material usually failed. She turned from the glass to her bench with the kind of urgency that feels like being pulled by gravity. All those charred leftovers she had cursed suddenly looked less like contamination and more like architecture. Through the night, she ground desert silica, ash, and polymer precursors into a slurry that resembled wet charcoal and storm sand. She layered it thinly, then roughened the surface on purpose, letting microscopic soot-like channels form instead of smoothing them flat. She fired sample after sample on the cracked cook plates, shocking them harder each round while dawn climbed over the desert ridge. Most attempts still failed, because breakthroughs rarely arrive as a clean trumpet blast and more often as a narrowing field of wrong. But one small tile came out scorched and intact, holding together after temperatures that had shredded stronger-looking samples for decades. She heated it again, and it held. She blasted it with rapid cooling, and it held. She cut into the layer and found a char-forming microstructure that redistributed thermal stress instead of surrendering to it. The miracle was not immortality, but intelligent sacrifice, a material that burned in a controlled way so the deeper structure could survive. After 23 years, she had not discovered perfection. She had discovered how to fail on purpose, at the right layer, in the right shape, at the right moment. That insight turned a dream into engineering. Data that once read like grief finally stacked into proof, and proof is the language powerful institutions pretend they value most. The same space agency that canceled her funding now sent polished teams up the mountain road to inspect the battered observatory. They stepped around peeling paint and boxes of failed samples while she handed them a material brewed from ash, stubbornness, and sand. When they tested coatings on re-entry capsule components, the layer held under brutal thermal swings that would have devoured conventional films. Suddenly, the scientist they had quietly filed away as finished became the person they called when expensive machinery needed a skin against hell. Yet the deepest victory was not watching agencies line up or seeing her once ridiculed work coat capsules heading back through fire. The deepest victory was understanding exactly why she had lasted longer than the rejection letters. She had built a system where failure was recorded immediately, grouped honestly, displayed visibly, and mined for recurring structure. She had reduced drama and increased evidence, treating every disappointment as a specimen instead of a verdict about her worth. That is the part viewers can steal today, even without a desert lab or a telescope shaking in the wind. Stop labeling efforts as good or bad and start labeling them by behavior under pressure. Write down what broke, when it broke, what conditions triggered it, and what held longer than expected. Keep your failed attempts visible long enough to compare them, because patterns hide when embarrassment sends everything into drawers. Look for the soot on the window in your own work, the accidental clue that only appears after years of paying precise attention. When resources are thin, replace fancy tools with better observation, because careful noticing often beats expensive confusion. Trade the question, how do I look for the question, what survives? Because outcomes care nothing about appearances. And if your progress feels ugly, uneven, and smoke-stained, remember that Mara's breakthrough came from respecting the scar pattern, not erasing it. Some victories are born in spotless labs, but others crawl out of wreckage because one person keeps turning evidence into direction. 23 years of failure did not block her breakthrough. 23 years of mapped failure became the blueprint for it.